Hello and good day. Today I have something which I think can be quite interesting. It may be a human error, but I have this Kinks module from Mutable instruments, and the guy who gave it to me said the sample on hold wasn't working. Well, that could obviously be true, but let's see if that's really the case. Before I turn it on, I do the same thing as I always do. I check for shorts on the power rails. So we have the ground here, plus 12 volts. Seems to be nothing there. Minus 12 volts. 200k. Am I not getting anything on the... Oh, yeah. I think it's safe to turn it on. And what I have for that is my Mutable Instruments module tester. Let me power it off real quick and connect power. Minus 12 on this side, and now I just turn on the tester and I see some lights turning on. So what we're gonna do first is, well, shall I cover the basics of a sample on hold? There's a noise generator in here, and that's what I'm gonna start with first, to check if the noise is being generated and exiting this output. You can also insert your own noise or whatever signal you want to get sampled. The trigger is just that, and whenever you pull the trigger high, the output is whatever the voltage was on the input or the noise at the moment you triggered it, until you triggered it again. I believe that's what the sample on hold is. So to check the noise, I'm going to attach it to the scope, and well, we already have some signal from the environment. Let's stick it in noise. I am getting something on my display here, which is, let's turn it back to default. The probe is ×1. I am seeing a voltage way down there. If I remove the DC component, we should actually be getting noise at this point. Well, I am getting a signal. I am getting a signal on my display here, but I'm not. Blah 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 blah. There's some. Can you see it rising? There's something wrong with the noise, it seems. I also see the LED continuously lighting, and if I go to the Kinks module and I remember reading something about on each trigger received on the trigger input, the output voltage takes the value of the input voltage and holds this voltage until a new trigger is received on the trigger. Well, we see 3 is the noise generator output, but it's constantly red. Yeah, it seems like at least the noise generator is not generating anything. So I think it's time to open it up. Because I already have the schematics ready, so we can have a look inside. And I'm really curious what could be going on. We know for sure, well, I'm pretty sure the noise output is not working. But it doesn't mean the sample on hold still is. But let's fix the noise first. If I can do that. There's no guarantees. So and here we have it. It is really tiny. So I might have to get the microscope out later to work on this. So yeah, this probably pretty much is sample on hold part. And if we take the schematic there, we see here 2 transistors, and I think they are both responsible for generating the noise. This collector is open, so this is creating noise in a way. Yeah, it is. And some filtering, some buffering, some gain. And here we have our noise out. And we're not getting anything there. So I want to see on IC4 if there's anything here. Let's check that for now. Alright, so I set some stuff up and we're going to measure the signal going into the op-amp at pin 2. And I have my oscilloscope ready. And let me ground our probe. And it's really tiny. And normally I do this under the microscope, but today I don't, because I want you guys to watch with me. This is the IC doing the buffering for the noise signal, and it should enter on pin 2. And if I probe pin 2, I only get a drop, a few volts drop. So that doesn't make any sense. Because why is there a DC offset? Let's try to find C10. If go back to the schematic, I am not getting a good signal here, so I want to check the signal here before the cap. This all gets summed together, and now we measure here. So let me find C10 real quick. So I got myself a fresh installation of Eagle, because Mutable is sharing all the design files with made with Eagle from Autodesk, and I haven't been using Eagle to design my PCBs for a long time now, and I've noticed it, yeah, well, it looks actually pretty good. And okay, but it's not important. Why did I do this? Because the silk screen print is so small on the real device here that even with a magnifier it's really hard to see what is what. And I was trying to find C10, and if we go here we can see C10 is located right here next to one of the noise inducing creating transistors. And R27, well, where is 29? So C10 and R29 are both connected to the noise output. So let's try to see. Let's turn it on again. Here it is. And let's see if we can measure anything on either side of C10, which is this one. And again, I'm just on one side, I'm getting the offset. Yes. If I measure over the resistors, Nothing there. Let's measure the transistors in there. I did manage to turn off the LED. I shorted something really short. Yeah, this is tiny stuff. I'm only measuring like how much? It's 1.5 volts down, either on the resistor, the cap. One side of the cap is 2 volts and the other side of the cap is 1 and a little. So what does that mean? What does that mean? Okay. Other stuff that we can know for sure is if we can measure VCC here. That's one thing. And this says here that it's a tantalum, and well, I'm not sure, but tantalums tend to fail as a short, I believe, which could explain what is going on. It could be either of these transistors, or it could be the op amp just draining it down. And let's try to get the voltage reels on the op amp as well. Now if we go here and we look for the OPA 4171, and if we look here, we can probably, well, let's do it the real way, the data sheet. And this is the 4171. This is the one that we're looking at, and we have like every quad op amp voltage plus on pin 4 and voltage minus on pin 11. So 4 and 11, like always. Are we still getting decent voltages on oh, I'm reading, sorry about it. Let's get it in there. So minus 11.6 on the minus reel, and I believe there are some diodes on the power input, which would explain the little voltage drop from 12. And this looks strange. Minus 2 volts on the plus rail. Am I doing this right? What are we measuring on input of the module? I may have some problem poking through any coating that is on here. I've seen this more and more recently on modern stuff, where you really have to press really hard on the contacts to make sure you get it. So we get 12 volts in. What is going on with this module? What is going on? Let's grab a ground. Minus 12 on that side. That's correct. Plus 12 on that side. So far, so good. And I see here what I believe are C7 and C8, and it's not on here probably, but C7 and C8 are the bypass caps for the op amp, so we can use that. To see what the voltages are. What is going on here? Because these voltages definitely do not make sense. I'm getting, yeah, this is, well, the 1.8 in mine actually looks like the offset that is shown on the oscilloscope. So what I'm going to do right now is, it wouldn't be the first time that actually the jacks with the normalization caused a problem by connecting like ground to the tip of the connector. So let's take these off, and then we can do some more measurements. The thing with these modern modules is that they use lead-free solder, which is obviously better for the environment, I guess, but it makes soldering and desoldering a lot more difficult, which is why I use some flux to help me. Desolder this stuff. Almost there. These things should come off pretty easy, but I'm not sure what's going on here. The fit is pretty tight. There it is. It's just some solder left inside, I guess. Let me help myself. There we go. It just needs a little bit more heat. Last one. Here we go. I will replace these just to be sure. It's really hot right now, so let's give it a moment to cool down. So it's cooled down, and now we can at least make sure there's no hardware problem with the jack sockets. Wouldn't be the first time, so it's always good practice. I also hooked up my lab bench power supply to measure the voltages or the current, so that we can see what's actually going on. So let's turn it back on. And it's not drawing any power on the plus rail. Nothing. There's 20 milliamps on the minus rail. Let's double check it again. This is easy because I can now just put my ground lead in the bench supply, and here we measure, come on, 12 volts, makes it, it's correct, makes sense, it's correct, minus 12, everything works as expected. And then we get to the bypass caps, and here we are again. We get minus 12 on the minus rail, but we get minus 2 volts on the plus rail. That makes no sense at all. Is the op-amp broken, or is something else draining power from the plus rail? The plus rail is not drawing anything, and if we this is the resistance on the minus rail, and this is the resistance on the plus rail, and as you can see, hopefully, yeah, it's not connected. There's absolutely, and if I measure the plus rail to here, it looks like the plus rail is not getting there. So it's going through this inductor. Let me show you what I'm trying to figure out. We have the power section here. This is the connector, and we have two diodes, and this is the minus rail. So that's the diode. Is there continuity between, let me check real quick in Eagle, see what I can find. Okay, I'll show you what I see here. So where need to go through the diode. Through the inductor. This is the plus rail. Checking for continuity between the pin now, is this because of the coating? Because I heard a short beep and then it disappeared again. Continuity. Ah, it's a really small diode, but okay, yeah. That's continuity. Now let's check the diode. It's really... Ah, I see what happened. Sorry, sorry. I see what happened here. If I had opened up the microscope and have a look inside, I think the diode is just missing. It looks like it's just not there. Yeah, I can see a diode on... It's really hard to see, but you can see a small black square on the right top, and there should be one here. Can you see that difference? It's almost impossible to see, but you can see there's clearly something missing on the top right. Now I am going to look at this under the microscope, because if there's no 12 volts coming in, and this, when I measured any possible shorts between the power rails and I didn't measure any resistance on the plus rail to ground, it would, I actually thought, well, that's not obvious, there should be some resistance, otherwise there's no path. And yes, there is indeed no path. So let me get the microscope out of here. And let me focus. And yes, the diode is missing. But did it blow? Let's measure the resistance again. Between what would be plus 12 normally between that and ground. And now we measure a resistance. That doesn't look like a short. Resistance is rising. So that's probably a cap charging. That's how I always think. I should look that up. That's what it is, what I think. If it is what I think it is. I'm going to look for a new diode, because that's something that I should have. It's this is 0402, maybe even smaller. Yeah, let's try to find it, and I'll get back to you. Okay, so I have a diode, but it's way too big to fit on here. But I can jumper it from this point to this point over here, and at least it gives us a chance to check it out, see if it works. So give me a short moment while I try to bodge this diode under, and when I finish that, I'll give it a spin to see if it works. So yeah, you can see it. It's a little bit too big for what's supposed to be there, but there's a diode there right now. I could also have used a little bit of jumper wire, or yeah, anything else could have worked, but now I want to see if there's any connection. There we go. Now we have a path for the plus 12 volt rail. So what I'm going to do now is limit my power supply to, let's start with 50 milliamps. 50 milliamps, come on. For this one, and 50 milliamps for the other reel. Yeah, both on 12 volt. Here we go. Turn it on. Now we're getting 20 milliamps on both rails, which looks normal. I don't have any signal left on the LEDs, so that's different than before. Now let's see if you can measure this noise output. Yes, here we go. Yep. Oh. So it's not updating very fast, but what we have here is, come on. So this interface is not always here we have it. This is the noise. Let me grab the front panel here and switch to this window so we can... What you see here is the noise output, sorry. This is obviously blank. We're getting our output. The trigger is blank, and on the output it's also empty. So this seems like it works. What I'm going to do is to clean this up a little bit and then reinsert some jacks. Yep, and then do some measurements again because I think this fixed it. And these really are a tight fit. Mutable probably uses his own footprints for stuff like this. And he maybe thought, or she, as of this point, thought, well, it's easier for manufacturing when the holes are a little bit smaller so they don't fall out, for example. And these really are. Come on, yeah, there we go. I hope it was still on frame. There's still a tiny bit of solder left in there, it seems. There we go. Only solder sockets when you have the front panel on, and at least give it a few nuts so that when we finish the model the sockets are properly aligned, because it doesn't matter how they're aligned on the bottom, but we do want something aesthetically pleasing. So here we have it. Let's get myself some leaded solder because it's much easier. And here we go. Still with a lid on the hot side. give it a check. Everything looks fine, so we can do all of them. This one needs a little more. That's it. So now we have the front panel back. And we can use the sockets again. Which makes it a little bit easier to give everything a try. -12 on this side. So let's zoom out a little bit again and put this over here. Here's not for now. Okay. So let's turn it on again. Hey, look at that. Suddenly it's turning red again. I am, give me a sec. I'm getting the scope ready again. So only one, and we have a ×1 probe, and no delay. And if we where is it? Where does it show my voltage peak to peak? Come on. Okay, it's not on here this time. Oh, I can clearly see we have a noise signal, and on the output there is nothing except for a tiny little offset. Okay. Now let's create a trigger signal. And I do so with the module tester, and I'm going to create a gate out once every second with a pulse width of, oh, let's shorten that, 1 millisecond pulses. Now we can see, can you? it's too slow to update on the computer, but I can actually see the voltage drop around every second, but only for really short. Well, the LED is it's showing the sampled value. I'm giving it longer pulses now. And if I increase the period to 2 seconds, and turn it to DC, and now we're getting something. Yes. I'm pulsing every 2 seconds now, and it's not always updating on the computer screen, but I can clearly see the voltage is jumping around every 2 seconds. Yep. Now let's put in another signal, because if we put in another signal, the noise is getting bypassed. And so I'm just sending a sine. (220 Hertz), 1 volt peak to peak. I will raise that to 5 volt peak to peak. And put that in, and now it's obviously not sampling because it's not on yet. And now is it updating? Yeah, you should be seeing this. I'm sending a slow sine wave in 230 Hertz, and you can clearly see I'll do a trigger every 5 seconds so the computer screen can update. Come on. Yep, there we go. Every 5 seconds it's lower and lower and lower. Can you see it? So it's sampling the sine that I'm sending into the input, a trigger every 5 seconds, and the output is showing just that. Okay. So that works. Turn it off. Let's just make sure that we get everything that we need. Everything is working. So I'm sending the same sine in what I believe is a rectifier part. Yep. And now I want to is that updating on and you can clearly see this is only half rectified and this is full rectified. So this is working. The logic max values and the min values, yeah, working is fine. I'll probably sum it as well. So yeah, I think I'll order a fitting diode. On the other hand, yeah, it's actually quite nice. And for a module of this price range, we don't want to bother too much. We're already playing around with it for an hour now, which I think is long enough. I consider this a fix. It is quite questionable though why the diode came off. The pads were intact. There was nothing wrong with it. Could have been a bump, a drop, maybe something. But then I would suspect the pads to be ripped off as well, and they're not. It looked perfectly fine. I could solder a new diode on there. Yep. Power issue. Fixed it. Happy camper. I'm gonna wrap this one up and get ready for another repair. Thanks for watching and see you next time.